Hello class, today's lesson is on Chapter 4, Standards, Measurements, Recipes, and Formulas. The objectives of this chapter are to define standards, standardize recipes, standard yield, standard portion, and standard presentation, explain the difference between a standard recipe and a standard formula, write a standard recipe and formula, convert units of measure, convert standard recipes and formulas to a new standard yield. Standards. Standards are rules, policies, or statements that's set by managers to help employees to perform quality tasks, produce quality products, and provide excellent service. These things are done by standardizing recipes that have a standard yield, a standard portion, and standard procedures. A standardized recipe is a written formula used to produce food and beverage items that are of consistent quality and quantity, more often referred to in baking and pastry kitchens as a standard formula. A standard recipe or formula is composed of a standard yield, the quantity of product the recipe produces, also listed as the total quantity or number of portions. Standard portion is the quantity or size of the product that is going to be given to the guest. You can measure this by weight, volume, count, or even the size of the container. Standard procedures, like performing tasks in the same manner, preparation, the plating, or even the beverage presentation can all be part of this standardized recipe. In larger facilities or corporate businesses, they'll take pictures of the food, post it so students and or employees can see the presentation of the food as they're looking at it, as opposed to trying to read a chart while they're in production mode. A standard recipe has a name, and it's organized by its primary ingredient, followed by modifiers. So in the example here, we would have lasagna as the formula name, followed by meat, tomato sauce. If we make a secondary lasagna or another variation or on a different menu at a different time, we might label it lasagna, vegetable, bechamel, breaking it down. The standard yield and standard portion, yields stated both in total quantity of product, like 3 gallons, and the number of stated portion sizes the product produces, 64 6-ounce portions. This is very critical when we start talking about costing and we're breaking down a recipe to know how much we actually spent on the ingredients used to produce that recipe and how many portions it is to produce that we then sell it for. This is the most common mistake that businesses and owners and even chefs don't do right, where they either forget ingredients, they didn't measure everything accurately, or they lose portions and don't get the number of yield that they're supposed to get. And every time that happens, you as the business have to eat that cost, because you can't just charge a customer more money because you weren't good at your job. So ingredients for a standardized recipe, we should be really looking at listing them in the order used. You've been in the kitchens most likely in our program here, or even in the business. It's very difficult to jump around on a recipe to make sure that you remembered everything, you didn't add it out of the right order or the wrong order, or you didn't mix up and you got sugar in 2 spots and put the 4 ounces in now as opposed to the 8 ounces and so forth. So we list the ingredients in the order that we use them on a standardized recipe. When the ingredient is used more than once, like the sugar example I was just mentioning, you list the total quantity where first used, followed by the word divided, or something like that. Each establishment has their own process for this, at least those that are aware of it. Those that do not often have inconsistencies in their product and production. You want to be very clear when listing the quantities. You've heard me or other instructors talk about weight, volume, and count for measures, and we've all told you that weight is the most consistent type of measure and most accurate. Volume and counts can vary based on your definition and my definition of a large onion, for instance. But when it's written on your standardized recipe, you do not want to have to make a guess as to the item that's listed. Is it a weight? Is it a volume? Is their large onion the same as my large onion? And that's what creates recipe inconsistencies. And if you're making it at home, it may not matter as much. But it also might be the difference between why that recipe didn't turn out the same way you wanted it to, in the way that you've had it, that made it so amazing, and why you wanted to cook it. So in a restaurant where you're pretty much producing this food for a menu day in and day out, or on catering and so forth, you're more likely going to have a procedure for your measuring, but you need to have that procedure in place. You need to train your staff on how to measure accurately and consistently, consistently and the importance of doing so. So in this example here, 1 6-ounce semi-sweet morsels. Is that a volume, because 6 ounces is 3/4 of a cup, or is it a weight? You could always just put a note on your standardized recipe that says all measures are in volume, or all measures are in weight, or all liquids are in volume, and all other ingredients are in weight. When in doubt, spell out the unit of measure, especially because you got to remember you're the educated person in this instance. Not all the people that you will work with or that will work for you have been educated to know the common abbreviation for quart or pint or pound. And what you want to do is reduce potential for risk of errors and inaccuracies and avoid wasting time, which costs money as well in labor dollars. It could mean product and very many other things. A 1/2 cup celery finely chopped. The reason that celery is finely chopped is the larger something is in a cup, it takes up more air space, so you don't actually get as much product. So if you measure it as stalks before you chop it, you're going to have an inaccurate amount, which then in this case would probably make your recipe or formula less flavorful because you'll have less celery than you actually needed. Again, if this was in a weight measure, 4 ounces of celery is 4 ounces of celery, cut up or not. When we look at standardized recipes, they should be created for every single item. In a restaurant, we thrive on consistency, and we die by inconsistency. Again, we've mentioned that it produces a known quantity, a known quality, based on the operation. Here's a card that kind of lays out some additional items that might be included. We've already talked about the name and servings, ingredients. Your directions are for home use. In a restaurant, we're going to talk about method of production or method of preparation. We also might include an ingredients list that are additional or variations of the recipe. We may also include an equipment list. Serving size we've covered as well. Total yield, that's always important. If it makes a gallon, that it does make a gallon, and that it's listed so somebody knows it makes a gallon, and if that's more, less, or the right amount of what they need. Serving utensils, unless you're in a production type kitchen that's really focusing on buffet style or portioning and high volume, the utensil's not always as necessary unless it matches the serving portion that you want to give. What I mean is, if you're on a buffet line at a college and a customer is going down the line and they want corn, you might have a size scoop utensil that will give the correct proportion of corn based on the costing that you've done and that student or customer will buy it for. Meal pattern contribution. This is where we talk about the number of ingredients to make the recipe, and you might actually start looking into nutrition when we talk about meats or meat alternates, number of servings like the grains or breads. Again, this kind of goes along with the whole my plate concept of how many portions. Watching your carbs or sugars, each slice of bread is considered one whole carb. So if somebody has a club sandwich that traditionally has either larger bread pieces or even 3 pieces, that's 3 carbs just in the bread, and not grams. A carb is considered every 15 grams of carbs. So each piece of bread is about 15 grams or more if it's a white bread, a milk bread, or a sugary bread. Serving suggestions, they might even often list alternative ways to serve it. If you're serving it as an entree, if you're serving it as an appetizer, if you're serving it as a soup, or if you're going to turn it into a canapé, because chefs have to work smart. So we design good recipes by trial and error, planning them out, practicing, and then we know that this lobster bisque would be great as a little 1-ounce shooter at a cocktail party in a little glass. So now we've done all the work one time, and then we just adjust for the function or the number of people or any other thing that might come up that causes us to change what we do day to day. Additionally, you can also see critical control points listed, the temperatures to keep the food out of, to keep it in, the critical limits that it must reach before it's considered cooked or safe to eat, to serve, and many other things along that. Here's another example of listing all those items. You also see on this one quantity as purchased, and the second one should be quantity EP, edible portion, and that would be what you ultimately need to make the recipe. That'll be in the final dish. The AP, as we've talked about before, would be the onion. If you need 1 pound of onion, you want to make sure that that's 1 pound after you've cleaned it, taken off the peel, chopped it up, cut off the root end and the core and so forth. Here's an example of a standardized recipe form. When we look at all the ingredients on the far left in number 3, number 2, we see all of the servings, we see directions or MOP, we have a recipe number, it's an entree, number 6, recipe name, and so on. You may not lay yours out exactly in this order or spacing, it just depends on your style. You can see it also shows the serving sizes down here, number 7. You can also see portion sizes for elementary or secondary, so you can probably guess this is a standardized recipe for an educational institution for their cafe. You can see portion size. If it's elementary, 1/2 cup, that's equal to 4 ounces volume. You can see down here meal pattern, 2 ounces, 3 ounces, vegetable, and that because each meal in this scenario needs to have X number of components from my plate, so it's a balanced meal for these children. You've all probably discussed this before, especially if you're a culinary or pastry student, but our measurement formats, there's weight, volume, and count. Just remember that weight refers to the effect that gravity has on something. It's its mass, its heaviness. It's expressed in terms like grams, ounces, pounds, tons. In America, we don't typically use grams as often. However, I will tell you, there is a smaller difference between 1 gram to 2 grams than there is between 1 ounce and 2 ounces. So what does that mean to you? What it means is your recipe is going to be more accurate and more consistent with less variance because you're measuring exactly, more consistency, or consistently with less variance. Volume is strictly the amount of space something takes up. Every room you're ever in, air is 100% of the space it can be. When you walk in, now you're part of that space. So when we take a measuring cup and fill it up to the top and level it, that is a volume because that particular container holds a certain amount, and now that you've filled it and leveled it properly, it now is equivalent to the ingredient you put in it. Count is the least indicative way to create a standardized recipe. Can you create a recipe with a count? Yes. Can you do so with a standardized recipe? Yes, it's just not suggested, and this is why. Again, we talked about the onion just a little bit ago, but size changes from grocery store, small and medium, to commercially bought, to different varieties of onion and so on. So you want to use count when the size or the weight is very, very consistent, or it doesn't vary very often or by very much. The other thing to remember is the staff that you're working with, if they're cutting up onions and they're not very skilled yet, they're going to have more waste or reappropriating the scraps and things to stock than is somebody that's more skilled. So that recipe can be altered just because you've given them the 2 onions, but they didn't use all of it because they were ineffective in their fabrication of it. So keep that in mind as well. So in the US, we call our method the imperial method. As you can see with weight, we're playing with pounds and ounces. In volume, that's where it's always more difficult because you can have a gallon, a half gallon, a quart, and so on as you look at this list. That creates a lot of flexibility or fluctuation in a recipe based on measuring and somebody's interpretation if it's not very clear, cut, and dry. In the metric system, you've got your gram and kilogram, volume, milliliters, and liters. If you look at Appendix A in your textbook, it provides measurement conversions from one system to another. And this was probably a great opportunity to give you a tip. If you have a recipe that you really like or you've developed and you didn't do it by weight, so it's all in volume or maybe it's a mix, you can always convert that recipe for all the ingredients to be based on a weight measure. And what you would do is mise en place all of your ingredients. You don't even have to worry about the equipment at this time, but just get all the ingredients properly scaled and measured based on the quantities listed as on the recipe. So in this case, let's talk about zucchini. We're making zucchini bread. So it says to shred it, so we shredded it, and it says 1.5 cups you need. So now you've got 1.5 cups filled, shredded, accurately measured. What you could do now is take it to a digital scale, digital is more accurate, and weigh the zucchini that fills up 1.5 cups. And what you've now done is you can convert your recipe from 1.5 cups to, say, 7 ounces shredded zucchini. So then somebody can either weigh zucchini and then shred it, or they can shred it and then weigh it to get to 7 ounces. I will tell you it'll save product and time if they weigh off the zucchini before they shred it. That way they don't over shred it or spend a lot of time going really slow trying not to create too much. Reading and writing a standardized recipe, you want to list the equipment and major tools required. All of you have probably done this at home where you started a recipe and you didn't have all the ingredients, or the one pot or pan that you needed wasn't clean, or it was dirty, or it was lost. That wastes a lot of time and makes you ineffective. So planning and preparing and completing mise en place 100%, or everything in its place, really promotes great execution. The steps should be in chronological order. You wouldn't put step 10, preheat the oven, if you were supposed to do it before you put the food in the oven on step 2. Various components, you want to list those steps separately. Oftentimes, recipes for home use are written in paragraph-long explanatory sentences. In a kitchen, reading is not the focus when you're trying to be speedy and methodical. So if you do bullet points or each new step as its own step, it allows you to be a little more speedy and organized and not wasteful on having to reread the recipe to make sure you've completed every step exactly. Stating exact or approximate mixing and cooking times. Just remember, cooking times are a guideline. In fact, a recipe is a guideline that somebody else created and now you're trying to execute. That does not always mean it's 100% perfect, even if it's standardized. For instance, jalapeno peppers in season versus out of season. In season, they're going to be spicier. Out of season, they're going to take longer to grow. They're not going to get as many nutrients, the sun, and all these things. And then when they do grow and they get harvested, they're usually larger. So all that spice is spread out more. So to achieve the same hotness, you might need more jalapeno, or you might need less because it's become too spicy. Same thing with almost every ingredient. Meats and proteins may be the one thing that's not as affected, unless you're talking about free range, local, organic, and things like that versus commercially processed and produced. And remember, with cooking times, it's the end result you're looking for. It says it takes 14 minutes if the oven hasn't been opened and the chicken breast is exactly 6 ounces and it's exactly 1 inch thick in the thickest part. But if yours is 1.5 inches thick, the cooking time can be thrown off by minutes. So remember, it's what are we looking for? Chicken in this case, we cook to 165 after carryover cooking. So we might pull it out of the oven 5-6 degrees early, keep it in a warm spot, let it rest for half the time it cooked, check the temperature again, and it should have reached to a safe zone. List serving recommendations, garnishes, serving temperatures, storage instructions. All of these things, again, ease your employees' angst when they're trying to produce a recipe to your expectations. It also makes them more speedy, and they always have a reference point to go to in case they get distracted in the middle of a task, which, as you all know, in the kitchen can happen. Chef, 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 and then you forgot where you were at. Recipe conversions. You all had to know this was coming based on the conversation we've been having. This is not supposed to be hard. This is not supposed to be scary. What it is supposed to do is allow you to change the recipe you have to make more, less, or to split it up differently, but have the identical same taste, identical same color, flavor, intensity, all of those things that you enjoy and what makes this recipe good. So the converting or scaling of the recipe is just to move every ingredient exactly up the same or exactly down the same so that it's not altered. If you do change from whole milk to sweetened condensed milk, it's a completely new recipe. And if it's in baking, it may not work. It may be too heavy and dense and fail or burn, or too sweet, or you use kosher salt instead of iodized salt, and all these different things. So when we do recipe conversions, we're looking at the yield most often, the total amount the product or this recipe makes, so that we can decide, do we need to go up, down, or split it differently. The working conversion factor is a term that I've kind of designed since I've been at Reynolds. At Johnson & Wales, it was the working factor. If you look in any math textbook or so on, it's a conversion factor. So I've combined it because it all means the same thing. It's basically the number that we come up with that moves the recipe up or down, or increase and decrease. When we're converting the total yield, we're going to divide the desired yield, the new, by the old recipe, or the old yield. Or we're going to take the recipe that we want and divide it by as is, or as it exists, before we've changed anything. So that's new yield over old yield, or which gives you the working conversion factor. The one item to remember on this point is that all items should be the same measure or same unit. You cannot divide gallons into cups because those two signs do not cancel. So when you got your working conversion factor, which is supposed to be just a number or a factoring, you would have a number that then has gallons and cups listed after it. So if you have a yield in gallons, the old, and you need it to be in cups, you would need to convert the gallons into cups. And at this point, hopefully you all know there's 16 cups in a gallon. If it's a gallon old yield and you want to convert it to quarts or something, you could do the same thing. And this is where your recollection or memorization of those standardized measures, you will be able to do it. Step 2, we multiply every ingredient by that conversion factor. And you can see here, old quantity multiplied by the conversion factor equals new quantity. And we do this again so every ingredient is evenly moved up or increased, or moved down or decreased, so we're scaling the recipe from what it makes to make more or less in the same ratios of the ingredients to each other. So here's an example. We're going to increase to 75 yield. The original is 30, and we divide, and that gives us a 2.5 conversion factor or conversion rate. To decrease it, we want it to make 15. It makes 30. We're now going to go ahead and divide that, and it's going to see that we're basically doing this recipe in half. Then we take that unit or the conversion factor. Again, these are two different problems here. One, we were asked to increase it. The other, we were asked to decrease the amount. So for tomatoes, when we're increasing, it's the same 4 pounds as the original recipe times the conversion factor. You can see to create this new recipe for the 75 portions, it's going to be 10 pounds of tomatoes. We're decreasing. It's the same 4 pounds we start with because of the original recipe, multiplying it by the conversion rate or factor of half, and that gives us 2 pounds that we need in our final recipe to serve 15 people. So again, as we're converting these, we're doing the same thing over and over. Additional conversion issues or challenges: equipment. When you scale a recipe, you don't automatically use the same equipment. Now, I'm not talking about using a stove or not using a stove, or an oven or not. What I'm speaking to is if you have a recipe that's scaled for 4 people, you might very easily be able to put 4 chicken breasts to sear in one pan at one time. But if now you got to serve 100, what do you do? Do you do the same 4 portions 25 times to cook all 100? Do you change the method and sear it and put it on a pan and put it in the oven? Do you need to turn the temperature down because yours are larger than they should be, or up because they're smaller so it cooks at the same rate? Evaporation. The taller the pot and more narrow, the less evaporation you have. The longer it takes to heat, the longer it takes to cook. The more shallow the pan or pot, the wider the mouth of the pot, the faster things evaporate. Is that what you need or not? That is something that isn't just automatically decided when you change the numbers of the ingredient amounts. The MOP needs to be changed by you and reviewed to make sure that it's going in the right direction. Recipe errors: if you've never made this recipe before, scaling it down could adjust it, scaling it up if it's not standardized, and so on. Cook times could change. All of these things are variables that you have to be thinking about once you change and convert a recipe. So here's a new topic within this chapter that we're going to talk about, and that is the baker's percent. And this is not as hard as students have made it out to be, so I will do my best to break it down and say it slowly and clearly. A baker's percent is all based on ratios. You've heard the term before. You might even been asked to answer questions about it or to understand it or take a test on it. But a ratio means the ingredients or the items listed are all related to each other. It's like a push and pull system. If I push something over here, it's going to pull the other item with it. If I pull this item, it pulls the other item. So what we're talking about here is the baker's percent is all based on the total weight of flour. Don't think about the text, what you've read yet, or if you didn't read it, but let's think about it this way. Think about flour just in its general sense. You all know flour, you've worked with AP flour, semolina, whatever it is. It's a dry product. It takes moisture to activate it, which would be water, milk, dairy. It could even be oil or fat like egg yolk because you're making pasta. The more flour you have, there's a ratio to how much liquid you need to make that become what you need it to be. And what I mean is the difference, if you remember, between a dough and a batter. A dough has less moisture. It's more firm and you roll it out and you shape it. A batter has more moisture, it's stickier, tackier, and it typically needs a pan to put it in to hold its shape as it cooks throughout cooking, like a cake. We've all seen pancakes. The thicker the batter, the less it spreads, the taller it is. Thinner the batter, the thinner or the cooler the temperature, it runs and spreads further and further and further, where you don't really have this nice, light, fluffy pancake. So in relationship to this baker's percentage, we're talking about flour. So that's always the 100% that we work off of. Everything else is a portion of that. Here's a basic list of ingredients that you know would make a bread. Flour, water, salt for flavor, yeast for leavening. So let's look at the next slide. Whether you're increasing or decreasing using the baker's percentage, flour is always 100%. And it doesn't even matter about the weight, because when you're doing this, it's about the specific formula or recipe, if you're not used to calling them formulas, that's in front of you that you're specifically working on right then. And again, it illustrates the relationship of all the other ingredients to the standard formula. The example I use is when Chef Lana used to work here. When she was in college, they had, as one of their projects in baking and pastry, they had to recreate the Krispy Kreme donut. You can't do that without a recipe. But that's a culinary set of mind. If you think about a pastry set of mind and look at this ratio idea, if you have X amount of flour and you add X amount of sugar, it gets sweeter and sweeter and sweeter and sweeter. So what they did is they reverse engineered it. So they took the Krispy Kreme donut, looked at it, tasted it, and started trying to figure out the proportions or ratios of the ingredients to the flour. How much water or milk or buttermilk was it to make that donut and make the dough? How much sugar went in it to get the sweetness? How much yeast did they have to use to get it to leaven? There's proportions to all of these things. And the baker's percent is much more precise because baking is a science. And we can base on it. We can't base a chicken on the baker's percent, one, because it's baking, but even if we did, chicken's not 100% of the dish because everything else goes into it and adds to it. And if you don't have it, it just doesn't have it. But if you don't have yeast, your bread doesn't rise. If you have too much salt, you kill your yeast. It doesn't rise. Too much sugar, your yeast goes crazy and it doesn't cook and bake in the right shape and size. So here we are. Now I'm not going to test you on the metric here. It's listed because it's in your book and if you have those questions. But again, this is the most accurate way to measure. So we've got flour, water, salt, and yeast. Our flour is 10 pounds. What did we say? Flour is 100%. So you can see right here. Water in this formula, because we've given it to you, is 6.6 pounds. If it wasn't here, but we knew water is 66%, meaning it takes 66% water to hydrate that flour to make the dough or the batter we need, we can take 66% of our 10 pounds, which is 6.6 pounds. And before we go further, when you add up the total percentage of your formula, you're always going to be above 100 because flour is 100. So everything else is on top of that. So right now we're at 166%. Salt to this much flour, so it's not too salty and not salty enough, it's 1%. 1% of 10 pounds is 1.6. Well, that doesn't make sense. Well, it's because you're trying to do it in your head right now. If you actually get a calculator, excuse me, if you actually get a calculator and divide this out, you'll remember that 10 pounds, there's 16 ounces in a pound, which would be 160 total ounces. 1% would be 1.6 by you moving the decimal. If you're not sure how to do that, we just divide it. Or, in this case, we take the 1% and we move the decimal here. What you would have done is divide it to get to this. 10 times 1, and it's going to give us our 1%, or the 1.6 ounces. Do the same thing for yeast. I've mentioned before, if you ever had me, but you should not taste yeast in a bread. If you do, they didn't make the dough properly, the yeast died, it was bad, and or you have too much yeast because they rushed the process to try to get it to rise and leaven faster. The right amount of yeast given in the right conditions will do its job, and you won't have this yeasty taste to the final product. In any matter, at 0.8%, this formula is telling us that that's enough to leaven 10 pounds plus 6.6 pounds of water, and the salt is to help control the yeast so it doesn't grow too quickly. Yeast needs sugar, by the way. If you're not a pastry student, you may not know that. Flour has carbs, and carbs turn into, yes, sugars. That's the end of the lesson. I hope that this benefits you by hearing it, being able to listen to it, and see it again and again and again until you learn the material. That this helps prepare you for this lesson as an introduction to our costing, our edible portion, our yield analysis, and all the other things that we're going to discover, explore, and try to understand throughout this course.